Now let's look at the actual implementation of how to interpret a select statement. There's a SQL parser, which is part of this examples/SQL of the course textbook, that parses a SQL statement, figures out whether it's a select statement or a create table statement. For select statements, it creates an instance of the following class. The select class represents select columns from tables where condition, where it's initialized with the strings that describe the columns and the tables in the condition. We store those, and we also create a make row. I'll talk about that later. What happens when you execute a select statement is that you have to join together the tables, you have to filter the rows based on a filter function, and then you have to map the make row function over the filtered rows. So now we have some clues about these different elements. Make row is the function that takes an input row and returns an output row. By mapping that over filtered rows, we'll get all the rows in the output table. Now the filter function looks and sees if there's a condition. Remember that the where clause is optional. So if there's no where clause, condition will be none. But if there is a condition, then we have to evaluate it using the current row. Now this is the version of eval that takes a Python expression and a dictionary telling us what the names mean, describing the environment. So in this case, we're just assuming that the expression syntax for SQL and the expression syntax for Python are close enough that if I call eval, I'll get the right result. The truth is it's not perfect, but for most of the cases that we care about, they will be the same. To finish understanding this execution, we'll have to talk about create make row and join. So creating row classes dynamically happens every time you have a select statement. A select statement is going to generate a result table. We need a new class in order to do that, and with the appropriate column names. And so we used name tuple in order to generate that. So create make row takes in a column description, and it returns a function from input to output rows. So we first have to break up the columns on commas. Then we collect all the expressions and their names for each column. So for every column in columns, if as is there, that breaks up the expression and the name. If there's no as there, then we just use the expression itself as the name. And we put the expression in the expressions, the name in names. Here is where we create a new class. We just call it row, because why not? But the important part is that it has, as its attributes, all of the names of the columns. Which means that we can return a function that takes in an input row, represented as a dictionary, evaluates every expression in our list of expressions based on that input row, giving us one column each from each call to eval. And now we have all the values that we need to put in our output row, so we just pass those into the row function, which is actually a constructor for a class. What about joining rows? Well, joining rows creates the dictionary that we use when we call eval on expressions. We're going to use a built-in function called product from the itertools module. And what it does is it gives all combinations of elements from several different collections. So it does the join. So what's the join actually do? Well, it splits up the names. It gets from the current environment each table by name and takes the product. So that actually does the joining of different combinations of rows in different tables. Now, once we have those joined rows, we need to make sure that we can refer to particular columns within them and that we can use their aliases. So that's what makeenv does. it creates an environment, a dictionary from names to values, based on the rows and the names that we've found. We've joined together multiple rows, and now we're going to go through each one and see if we can find its field name and add that to the environment. So in this way, if I join together two rows and one of them has a column called parent, I will now have in my environment parent bound to the value for this particular row so that I can look up the parent value when I want to evaluate an output column or a where expression or an order by expression. And then we're done. So this is the core part of the implementation for executing SQL statements. If you look through the example file, you'll see that there is a fair amount of other stuff going on. We need to tokenize the input. We need to parse it to find out where the select statements are. But here, if it finds a select keyword, it finds the from, the where, and the order by clauses and puts those together into a select object. And the select object, as we expected before, puts together the columns, the tables, the condition, and the order, and then execute those just like I said. This version has sorting as well, so that we can support an order by clause. In addition to select, there's union, which just yields the rows from both a left and a right table, and there's create table, which gives a table a name. But that's the whole implementation with a few helper functions, and we're done. With this, we can actually run sql.py and do things like select hello. We can even take our whole example that we built before and run it through this implementation of an interpreter for SQL, and it will print out all of these funny sentences that we talked about. Dog and cat chased bird and cat. What if we wanted to make it a little bit more like English? Well, I could put the dog and the cat and the bird, and by starting over, I'll get perhaps something that looks more reasonable. The cat and the dog chased the bird and the cat. And that's our interpreter. I suggest that you spend some time reading through the program so that you understand how it works.